You may wish to press pause to review this question before we make a start. Okay, I've read it and I am looking at part A, which requires me to find the vector OP in terms of IJK. And I noticed that I can do that based on the information in the first sentence. That means I want OP to be of this form. I'm going to use my subscripts we saw earlier in the text, A subscript 1I, and plus we need one in the J direction, A to J. Now what we do know is that cos alpha will equal, it is equal to A1 over the magnitude of OP, isn't it? Okay, so from there we get this. We know the magnitude, so cos alpha is equal to A1 over 200, because that is the magnitude of the vector given in the question. And by the way, alpha I should have put in 135 degrees instead. And by rearranging and understanding that cos 135 is the same as negative cos 45, I can say that A1 is equal to minus 100 root 2. I wanted to rationalise the denominator here. Now to find the J component. Well, we know that cos beta is equal to A2 over the magnitude of OP, which we already know, it's 200, isn't it? So what have we got? A2 will equal 200 because the magnitude of OP is 200, cos, and the angle I'm interested in here is right here, it's 45 degrees. And that's what on root 2. So A2 is going to equal, rationalising the denominator, etc., etc. It's just the same as before, except not negative, 100 square root 2. So OP, I'm going to write it over here. The vector OP can be described as minus 100 root 2I plus 100 root 2J. Now from P, which I'm now going to put here, she just walks 15 metres due north to Q. Okay, 15 metres due north to Q. Well, that little vector, PQ, that makes it easy to describe, doesn't it? All it is 50 in the J direction. So to find OQ, we just add OP and PQ. So just on my very rough diagram here, what we are doing is finding this vector here in rectangular components. So we just add the vectors, and you can see my working out there. The only tricky bit is adding your J components together. I don't think we want to factorise in terms of 50 particularly, so that would be my final answer for OQ. Next we want to find the vector QT. Well, QT is from point Q, and it's directly, point T is directly above it, isn't it? So that'll be straight up the Z axis. Now what are we told? She walks up 30 metres vertically above Q. So really, QT, the vector QT, is simply equal to 30k. And now for the thrilling conclusion. We're going to find OT, so from start to finish. All right, so all we need to do is add QT to OQ, isn't it? That's all we've got to do this. That maps out her journey. OQ plus QT will be what OT is. So we just note that down. OT is equal to OQ plus QT. And in other words, we have quite basic arithmetic to do. What have we got? OQ is, there it is in green. It's minus 100 square root 2i plus the messy bit, 100 root 2 plus 50 in brackets j, and then we've just got to add in qt, which is just the k component, which is 30k. And that would conclude our answer to this question.